Welcome to the course Digital Human Modeling and Simulation for Virtual Ergonomic Evaluation. Today we are going to discuss about our 6-week course module. So, in the first portion we will study the techniques of virtual ergonomic evaluation. Already in our earlier module we have discussed about reach analysis, clearance, vision, then comfort discomfort analysis, spinal load analysis. So, following those analysis, today we are going to discuss about ingress egress analysis in module 6. After ingress egress analysis, then we will move towards industry specific. If you see in week 6, so we are going to discuss ingress egress analysis as the application of virtual ergonomic evaluation technique. In the next we will discuss about application of digital human modeling software in various industrial sectors. So, first we are coming to ingress egress study. So, ingress egress is very important not only for vehicle workstation, for other workstation also. In vehicle workstation, drivers as well as passengers, they enter and exit from that vehicle. While they are entering inside the vehicle or coming out from the vehicle, there are different types of problem they face. So, how we can improve that vehicle design so that their problem for entry exit can be minimized. Not only this type of vehicle, but also in other situation like not only this passenger car, other say bus or truck, train or even military vehicle where there are so many other constraints in that design. So, how passengers or driver enter in their respective sitting places and how they come out from that vehicle, that is very important to study from ergonomics perspective. So, in this particular slide, these images taken from the book written by Vivek D. Vishe in 2012 on vehicle ergonomics. Here he mentioned various dimensions of the vehicle which are related to ingress egress. So, he mentioned about the location of B pillar, then lower edge of the upper door opening, this position, then upper edge of the rubber seal over door rocker, this point, then outer edge of the rocker panel, this one, then thigh clearance space between the seat surface and bottom side of the steering wheel. Apart from this, another important dimension for this purpose is the rocker width in the distance from the outer edge to the inside edge of the rocker panel. So, this distance is also influence that whether this entry and exit or ingress or egress for the driver, how this, if this distance is more, then there will be more discomfort for entry or exit. So, wide rocker panels make the entry exit difficult as it requires wide lateral step. So, the person who wants to go in from outside inside the vehicle, then he has to go for his leg or the whole body has to move from this point to this point, mean it requires wide lateral step. Next. So, while passengers or particularly in this case driver, while drivers are sitting on the driving seat, then different percentile driver means shorter, average and larger driver, they and also other particular population say older people, obese and mobility challenged people, they find different types of difficulties during entry exit for the driving seat. So, driver with lower edge, driver with short legs, what types of problem they face. So, from here you can see seat and top rocker panel, they feel that seat and top rocker panel is too high. It means the rocker from the rocker panel to the seat height is higher for them, because they feel their leg is shorter. So, they have to lift the leg more. Then step over is too wide. that in the earlier slide, as we mentioned, this one rocker, if rocker width is more, then they have to move their leg more. So, step over is too wide, then the clearance between the driver knees and the instrument panel and oblique or the steering wheel is insufficient. The space between the, because generally the driver with shorter leg length, they have to move the seat forward. While they are moving the seat forward, the space between the instrument panel and the steering wheel column, the space from the knee of the driver with shorter leg length is actually, that space is reduced, because they move the seat forward. While they are moving the seat forward, then they find that clearance between the knees and that instrument panel is less or insufficient. On the other hand, older, obese and mobility challenged driver, while they are sitting or going to sit on the driving seat, they find different types of problem. They feel the seat height, the seat is either too high or too low, indicating difficulty in climbing up. So, for them, because either they are older or obese, they feel they have to lift their body and have to go inside, or from the seat they have to lift their body and they have to come out. So, they feel that seat height is too high for them. At the same time, step over is wide. Upper part of the window opening is low. Upper part of the door opening is low, because for them bending is the problem. So, as they cannot bend their neck more, or the overall body they cannot bend, they prefer to enter as much as possible in a vertical position. So, for that reason, they feel that upper part of the door opening is low for them. Otherwise, they have to bend more. Clearance for thigh and tummy are insufficient, and for particularly for obese driver, the space from the tummy to the steering wheel is not sufficient. Similarly, driver with tall torso, they have different types of problem. While they are sitting on the driving seat or they are entering in the vehicle or coming out, they feel upper part of the door opening is low, because their height or stature is relatively more than the others. So, they need to bend more while they are entering in the vehicle or coming out from the vehicle. F pillar is close to their head while bending forward. So, while they are bending forward, then they feel the location of the A pillar is nearby their head. The head clearance is insufficient due to their longer torso. The clearance space above their head and the vehicle roof is not sufficient. So, these are the feeling of the tall drivers with tall torso. On the other hand, drivers with long leg, they have different feelings. So, while they enter in the vehicle, they are either going for ingress or egress in a vehicle, then the seat track does not extend sufficiently rearward. To accommodate their long leg, they move the seat backward, but while they are moving the seat backward, they feel that seat track travel limit should be more in backward direction, so that they can accommodate their longer leg. The frontage of the B pillar is too far forward, and the B pillar, while they are moving the seat backward, then the B pillar coming towards their head, because they are shifting their seat backward. So, they feel that B pillar position is too far forward, it should be little bit backward. Leg room is insufficient to move the legs from ground. The leg room is insufficient to move the legs from ground to inside the vehicle. As their leg length is more, so they feel that leg room is not sufficient for them. The space between open door and the vehicle body is insufficient. Due to their longer leg, they feel that the opening space from the vehicle body and the door, that should be more, so that they can turn their leg, longer leg, and they can enter in the vehicle. So, this is taken from Vivek de Vishay book written by Vivek de Vishay. So, from that book, so these are the feelings of defined for a particular vehicle while the driver are entering in that vehicle in the particular passenger car. During the entry or exit process, different types of driver have different opinion or their feelings are different. Someone feeling that, so these are the 4 categories of people he mentioned, that people with driver with shorter leg, driver with long legs, driver with tall torso, similarly obese, older and mobility challenged driver. So, what are their feeling? Because this entry exit performance of drivers and occupants are affected by combination of factors, that vehicle dimension and various components dimension of the vehicle, at the same time characteristics of the driver or subjects or passengers. So, who are going to enter in the vehicle or coming out from the vehicle, their characteristics, in their physical characteristics, whether they are thin or fat or their body dimension, their somatotype, that is important. At the same time vehicle dimension, say roof height, step height, door opening size, so all these factors are actually very important. So, in this particular slide, if we take the example of this army vehicle, so in this army vehicle there are different entry exit point. So, apart from this normal door for entry or exit, there are other routes, like at the top there is hatch. This hatch is used for firing, but this is also they can use for their emergency exit or exit for while they require. Similarly, on the vehicle floor there is sewer hatch. So, through the sewer hatch they can also go down. So, dimension of those exit points also we have to design as per the body dimension of the intended user population. So, obviously, the dimension should be such that people with larger body dimension can easily pass through. So, in a vehicle, not only this type of normal door, that sidewise or at the back, that back door where there is ladders or stairs, apart from these 2 types of door, side door or front or back door, there may be other entry exit point, like as we mentioned that sewer hatch or overhead hatch. So, while in specific type of vehicles, this type of provisions, different provisions are there for ingress egress, then all those points we need to evaluate and we need to design as per the requirement of the intended user population. So, we have to ensure that people with larger body dimension can easily go in and out easily. Now, in subsequent slides, we will discuss about various research papers where researchers have used digital human modeling software to study ingress egress or to demonstrate how digital human modeling software can be used for effective analysis of ingress egress, and vehicle design can be modified to ensure comfortable and ease entry exit. So, in this particular slide we are going to discuss from the paper, research paper by Wang et al. 2013. So, in their paper they demonstrated how motion capture and its application for vehicle ingress egress. So, they demonstrated that motion capture system can effectively be used for vehicle ingress egress analysis. They proposed systematic approach to incorporate motion capture test and analysis in an integrated environment for vehicle design for analyzing human motions during vehicle ingress egress process. So, for that purpose they developed this type of test mock-up where real driver can go into that driving simulator or mock-up, and that time data can be collected using motion capture system. So, what is this motion capture system? Motion capture system is actually camera based system, generally IR camera, infrared camera, which track markers or position on the driver's body, and those camera actually track those markers location, and based on that markers location actually in that from the captured data by the camera, it is transferred to the software, motion analysis software, and in that motion analysis software, based on that marker position, 3D model of linked segment is developed and various types of body joint angle can be evaluated. So, this motion analysis system actually captured the human motion, while that real driver is entering in that simulator. So, in the study they use motion capture system, at the same time reaction force measurement system and contact force measurement system. So, all these they used to get different types of kinetic data, kinematic data as well as contact force data. So, those data particularly that motion capture data they transferred to digital human modeling software, that is in the CATIA. Here they used CATIA software. In CATIA software, that following the real human trial, real driver trial, the data collected through motion analysis system, camera based motion analysis system, that data transferred to digital human modeling software CATIA, and in this software then they evaluated that how ingress egress process can be evaluated in virtual environment of CAD software. So, this is visual simulation of digital human modeling. Then with that CAD software, this is the foot and head swept volume. So, while the digital human modeling is entering in that vehicle or coming out, so this is actually the profile for their foot and head swept. So, this portion is for head swept, mean how head is moving from outside in the vehicle or coming out from the vehicle. Similarly, for the foot, how foot is going from outside the vehicle to inside, or while the driver is seated on the seat, while he is coming out, that how feet is also coming out. So, this is actually the swept volume for feet. Similarly, this is the swept volume for head. They also analyzed the swept volume for the leg. So, it is represented here. Then this is the section cut of foot and head swept volume at door opening. So, this is for the swept volume for foot and this is the swept volume for head. So, following the swept volume, actually this cut section can be defined. So, how much space actually required so that driver can go easily and come out from the vehicle without collision at any part of the door opening. So, for this, so the data which was captured from motion analysis system, that has been transferred to CATIA, this digital human modeling software, and from digital human modeling software we can evaluate at what should be the optimal size for the door opening. So, that based on the foot swept, leg swept and head swept volume. So, in this way, without real human trial, we can use digital human modeling software, and based on the digital human modeling software analysis, we can design the door opening, or we can define what should be the optimal door opening. So, they concluded this evaluation technique actually avoid costly steering bark builds and construction of and conducting real human trials. Then it also helps in decision making process from pure subjective driven to data driven. So, otherwise what is required? We have to go for real human trial, we have to ask their comfort, discomfort during entry exit, but in this case with this type of software, digital human modeling software, based on the motion analysis data, we can easily create this type of swept volume for different body parts, and based on that swept volume we can define the sizes of the door opening. So, ultimately their study indicated that digital human ring software is actually very useful for ingress egress study of vehicle, and how the design of the vehicle component, particularly say door opening, can be modified as per the analysis, ergonomic analysis. Next, in another paper, Liu et al. 2013, they also demonstrated that ingress egress motion strategies for elderly for the rear seat of minivans with sliding door. So, in minivans, so their research is in this particular case is related to minivans, and that is the rear seat. So, while elderly people sitting either going in or coming out, mean entry exit for the rear seat of the minivan. So, how elderly people's behavior is different from the adult people, not young adult people or adult people. So, they conducted one study. In the study, 10 elderly male subjects and 10 adult male or young male subjects participated. And from this, they investigated that elderly people's strategy while entering and exiting from the rear seat of minivans with sliding door, how is it different from young people. So, minivan mock-up with 4 adjustable parameters at 3 levels each, including roof height, door height, floor height and seat height. So, these 4 variables they considered, and they make all these things adjustable at 3 different levels. So, this is the mock-up, and experiment this is the real human subject who is checking that experimental setup. While driver in that experimental setup, while driver is going in and coming out, then the data is actually recorded. So, while real driver or elderly people is going for sitting on the minivan seat or he is coming out, then his joint angles and position of joint centers at 15 joints are adopted to represent the kinematic of motion. So, their body joint angles changes during this entry exit process are recorded using motion analysis system. So, based on the data, it was identified that during ingress motion 7 different strategies are actually adopted by the people. Most elderly passenger prefer standing on the floor with both feet first and then sitting down. So, elderly people's, so what they identified, the elderly people's ingress strategy is actually different from young adults or adult people's ingress strategy. So, there they have shown different steps from while the person is standing outside of that vehicle and gradually step by step moving in and ultimately sitting on the vehicle seat. So, this is the total sequence for ingress. Generally, out of this sequence, they identified that specifically there are total 7 different strategies which are adopted by the drivers. But elderly people generally prefer they first stand on the floor beside that vehicle door and then with both feet they move towards the vehicle and then sitting down on the vehicle. After that they put both the hands on the center pillar or the front seat support to support the body weight. So, most elderly people, how their what is their strategy? They first stand, then sit on the seat and then hold the center pillar, either B pillar and otherwise the front seat, and they gradually took the legs in. Most young people tend to move, on contrary, what young people do? Most young people tend to move the inside leg onto the floor first, then sit down, then move the outside leg in. So, young people's strategy is different. So, they do not follow the like older person or elderly person. They do not sit on the seat first. What they do? First they put their one leg inside, then they sit down. After that they pull the another leg inside. So, there is significant difference between the strategy followed by elderly people and young adult people. Similarly, there is also difference in egress motion also. So, egress motion, if you look at that egress motion, there are various steps. So, initially that driver is seated on the seat and gradually coming out, step by step coming out and ultimately standing outside the vehicle. So, from that minivan rear seat, while that drivers are coming out, that ingress motion is actually different for young and elderly. Both young and elderly passengers take the outward strategy most, which started with moving the outside leg out, then standing up and finally moving the inside leg out. So, first they move their one leg out, then they stand up and finally moving the inside leg out. But elderly passengers require more hand support on the center pillar or the front seat. So, in case of egress motion, although their strategy to some extent similar, but in terms of support, elderly people actually require more body support on the center pillar or on the front seat, and based on that support they gradually comes out. So, this is from their study, Liu et al. Actually demonstrated that motion strategy for going in or coming out from the vehicle is actually different for not only for different individuals, also there are different types of strategy, and the strategy adopted by older people or elderly people is different from the young adult. In another research paper, Karmakar et al. 2011, they demonstrated how digital human brain software can be used for ingress egress analysis in army vehicle. Particularly in this paper, they demonstrated how the entry exit process through the rear door of the army vehicle can be evaluated. So, from the existing army vehicle, they developed the CAD model, and that CAD model was evaluated with different percentile of army population, starting from 5th percentile to 95th percentile. So, it was observed from their study that even the steps or ladder which is existed in the existing vehicle, that is actually not properly designed. Not properly designed in terms of the national international standard, that was not followed, because if you look this particular image, the raiser height from ground to first step, from first step to second step or second step to vehicle floor, these raiser heights are not uniform. So, these are varying. So, as this raiser height is not uniform, so during while the army personnel are going or are in hurry or taking or carrying load and going inside or coming out, due to that rapid movement they may fall down, there is chance of accident due to this uneven distribution of the riser height. So, following this analysis, it was recommended that this height should be riser height should be uniform. At the same time, it was also observed from the study that these dimensions of the steps are also different. So, this may also lead to error and accident. Apart from this, in this particular vehicle, the space from ground to the roof, the vertical space or the opening of the door is not sufficient for entry, comfortable entry even for 5th percentile soldier or 5th percentile army population, because the design was constrained by some other criteria. So, following this virtual ergonomic evaluation of the existing CAD model, it was clearly identified that what are the problems in this design existing and how those can be overcome by design solution. In another study, Baker et al. 2013, they investigated vehicle egress by military personnel following accident. So, in normal situation, in many research paper, it has reported that how ingress egress can be evaluated for different types of vehicle. But in this particular paper, Baker et al. Demonstrated that ingress egress strategy is actually different while that vehicle, particularly military vehicle, is under is facing any accident. So, following accident, the ingress egress strategy is actually different. They cannot come out through normal entry exit process. Based on post accident scenario, ingress egress would be different than the normal. Human motion simulation framework reference implementation was used for the simulation, in this case using JAX software. Mannequins 50th percentile and 90th percentile male are created using scaling based on Ansur anthropometric database. So, in this particular case, they use JAX software, and for developing digital human being software, they refer this anthropometric database. Problem related to post accident egress strategy, specifically basic clearance issues are demonstrated for the vehicle. So, in normal case, they can enter through the side door, but in accident scenario, they may have to, that driver or that army personnel who is driving that vehicle, they may have to come out through the windshield. So, while they are coming out from the windshield, whether the space provided in the windshield is it sufficient for coming out the person with the arms and ammunition attached with his body, or the backpack attached with his body. So, this is very crucial, or this fact should be considered during army vehicle design, because following accident that person may, that army personnel may have to come out through the windshield opening. Similarly, then it was observed that actually the opening was not sufficient and there is collision with the body and the vehicle parts. On the other hand, if so, there are two types. So, one is windshield egress, may be by that person, that army personnel of his own. Otherwise, it may be assisted egress, mean some other army personnel helping that person to come out. So, in that case, whatever is the opening, door opening size, is it, whether is it sufficient for assisted egress, that the now he is not coming out in normal, following normal egress process, his body has to move and that body has to come out like this horizontal posture. So, these various issues has been demonstrated, and accordingly they suggested that what type of modification in this army vehicle to be implemented. There are various research papers related to ingress egress for different types of vehicle. So, we will discuss few more research paper here. So, in this slide we are discussing the paper by Baumann et al. In Baumann et al. They evaluated ingress egress using digital human model in heavy vehicle development process. In the heavy vehicle development process, they use digital human modeling software JAC, and they demonstrated how to position not in this case, Baumann demonstrated positioning of grab handle for reach analysis. So, where in that vehicle through that while that a person or driver is going in that driving cabin. So, where that grab handle should be positioned. For that purpose, they evaluated the reach, two types of reach. One is this type of they created reach envelope. Based on that reach envelope, which area is actually while that person, in this case they considered as the reach envelope, reach for the people with shorter body dimension will be smaller. So, they considered 5th percentile female model. So, for 5th percentile female model, they developed the reach envelope, and based on that reach envelope, they identified where should be the position of the door grab handle. So, that person with smaller body dimension can hold the door grab handle and can go inside. Similarly, so in this case, based on reach envelope, at the same time, while that using the digital human modeling, they demonstrated how the dimension of the door grab handle should be decided. In that paper, they also Baumann 2001, he also showed that how stability can be maintained during ingress egress process. So, maintaining stability, 3-point contacts to be maintained. So, these 3 points are either both hand and one leg or both leg and one hand. So, these 3 points of contacts to be maintained for maintaining the stability. So, they demonstrated while the driver is putting his leg on the steps for climbing to that vehicle driving cabin, then while driver is putting 2 hands on the, one is here and another is here on the grab handle and 1 feet on this particular step, then this is the triangular space that is actually defining the 3-point contact, and this is the area of this area, and this is the area defined by this 3 contact point, this triangular area, and the center of mass of the body, whether the center of mass is nearby or within this triangle or it is away from this triangle. Based on that, they evaluated the stability. Stability can be evaluated based on the position of mannequin center of mass in relation to the area defined by 3 contact points. So, with digital human modeling software, here they use JAC. So, they clearly demonstrated that how during ingress egress process, by using these contact points and also the projected center of mass, how stability can be defined, and accordingly design can be improved. So, these are the various references which has been used in earlier slides, in these slides, but there are so many other research paper where various researchers have demonstrated how digital human modeling software can be used effectively for evaluation of ingress egress process, for driving cabin or in the crew cabin, and also for specific type of vehicle like army vehicles. So, I suggest all the students to explore more in this regard, download more research paper and go through, then you will get clear idea that how digital human link software are actually used for ingress egress study. Now, in the next section we are, so in earlier section what we discussed? We discussed ingress egress study, and in our earlier modules we discussed different types of ergonomic evaluation which is possible with digital human link software. Now, in the next or subsequent slides we will discuss about how digital human link software is being used by various researchers in various industrial sectors. So, in this slide this is a representation that digital human link software is nowadays used in almost every occupational setup. It may be defense research, it may be computer aided engineering or automobile assembly or aerospace technology or industrial application, industrial shop floor evaluation or healthcare application, various types of service industry. So, everywhere there is application of digital human link software, and researchers, designers and engineers are effectively using this software for virtual ergonomic evaluation and getting benefit out of this software following this virtual ergonomic evaluation and design modification of those workplaces. Now, we are going to discuss about how digital human link software are being used in automotive industry by various researchers and engineers. So, in automotive design process, digital human link software is actually used for both vehicle occupant packaging, mean how that driver cabin or passenger cabin can be designed as per the requirement and ensuring comfort of the driver or passengers. Not only for vehicle occupant packaging, it is being also used in digital manufacturing, in the automotive manufacturing shop floor. So, this schematic diagram taken from book written by Rikkas 2012, where he demonstrated that generic occupant packaging process in the vehicle development. So, vehicle development process is starting here. So, first there is concept freeze, then style freeze, then process development, then production start, and then vehicle in the market. So, in the product development there are various steps: conceptual packaging, where find SRP position, then track travel length, reach, postural comfort clearance, all these are involved. Then in the next phase, styling or design, vision, reach, all these things needed to be considered. Then in engineering or ergonomic review, so advanced design review, user scenario, all these things should be considered. So, in each of these steps there is use of digital human link software. So, digital human link softwares are very important in occupant packaging, that is for driver as well as for other passengers. Cavatura 2014 demonstrated how digital human link can be used for evaluating various human factor issues in motor vehicle design. So, they studied various issues like habitability, accessibility, reachability, internal and external visibility, and seating comfort. So, using JAX software, they demonstrated that while driver is going in or during the ingress, how different areas of reachability for the handrails for each step for various percentile of driver, 5th percentile, 50th percentile, 95th percentile. So, all those. So, while step by step, while the driver is going in, then where is their hand reach position. So, with different colors, color coding they have used, they have demonstrated that how is the reach for 5th, 50th and 95th percentile driver. So, based on this analysis, it would be easy for positioning the grab handle. For sitting arrangement or sitting comfort, they with 5th percentile, 50th percentile, 95th percentile digital human model, they position on the seat and evaluated various types of driving seat related parameters. Then also they studied reachability. In reach analysis, two types of reach they evaluated. One is normal reach, creating reach envelope, that while reach envelope is created, that which areas of the control panel or different components on the dashboard can be accessed by the driver, that has been evaluated. At the same time, reach by extended arm. So, how much body joint movement is there for accessing a particular control or particular component in the vehicle, that is also evaluated. Apart from that, they also in that study it was also evaluated the vision, the visibility of a child located outside the vehicle, that whether while one child is located outside the vehicle at different distance, at which location that child is visible to the driver and which location it is not possible. So, these different aspects in motor vehicle development has been studied by Cavatura in 2014 in the research paper. In another research reported by Godwin 2008, Godwin et al. 2008 investigated the line of sight issues from operators seated position within the cabin of a load haul dump machine, LHD machine. So, in load haul dump machine, that virtual modification, virtual design modification yield line of sight improvements for LHD operators. So, ultimately in their study they used JACK software, digital human software JACK, to assess the line of sight and visibility related issues. Design of the load haul dump vehicle were modified, demonstrated how external visibility can be improved following virtual ergonomic evaluation using DHM. So, in this particular image they showed that while that LHD is positioned beside a tunnel, so which area is actually visible and which area not visible. So, for that purpose they created 10 meter into 12.5 meter grid, a forward grid position at 1 meter height for a visibility audit using eye height corresponding to a 50th percentile height and weight male in stationary seated position. So, they created one vertical plane in front 1 meter away from that driver sitting position, and the driver which they considered, that is 50th percentile driver, mean driver with 50th percentile height and weight. So, while the driver is looking outside, which area is actually visible to him. So, this is on this particular plane they demonstrate with these dotted points that these areas is actually visible and this area that actually not visible. So, easily visibility external visibility from that LHD can be evaluated using this JACK software. they clearly demonstrated that. Not only that visibility, they also checked that how this line of sight as well as external visibility can be improved by redesign various components of that LHD machine. So, these are the various components of the LHD machine. They modified, this is the modification, and following modification they again analyzed how the external visibility has been improved. So, they clearly demonstrated that digital human being software can effectively used for design modification, and based on the design modification that range of visibility, external visibility can be improved. Next, in another paper, research paper, this is published in 2001 by Baumann. So, in that research paper, this paper is actually related to using digital human modeling in virtual heavy vehicle development environment. So, in heavy vehicle development environment, how digital human modeling can be used. So, Baumann demonstrated digital human modeling can be effectively used for analyzing reach and vision requirement as per Federal Motor Vehicle Safety Standard. So, following Federal Motor Vehicle Safety Standard, how various ergonomic issues can be evaluated in that heavy vehicle development. So, they created reach envelope and also identified that collision during different types of operation. So, they created arm and leg reach. They analyzed arm reach for the various components as well as leg reach for leg control operation like the clutch, accelerator, brake for this purpose. At the same time, the reach envelope for studying the overall reach on the instrument panel. So, both reach envelope, by creating reach envelope, at the same time target specific reach they evaluated. Apart from reach, in this paper they also demonstrated how vision analysis tool of digital human being software can be effectively used for evaluating the position of dashboard display on the dashboard. So, this is a view of left eye view. So, vision instrument panel on the dashboard, vision analysis. So, for that purpose view cone can be created, eye view window can be created, then there is single eye view, both eye view. So, these are the various tools available in the digital human modeling software. Using those tools vision can be evaluated. So, here this is the visibility of the left eye view, and in this image it is shown that with 30-degree view cone which area. So, this is the 30-degree view cone, with 30-degree view cone which area of the instrument panel is actually visible to that driver. So, in 2001 they with this JAX software, the Baumann et al. Clearly demonstrated that digital human being software can be effectively used for positioning various components in the vehicle and also checking those position and arrangement of various controls inside the vehicle workstation. Henson et al. 2008 in their research paper Digital Human Modeling in Automotive Product Analysis, they demonstrated how digital human being software can be used for automotive product analysis. So, anthropometric postural variability of the targeted user they considered. So, anthropometry as well as the posture of various percentile driver they considered, but they did not create like 50th 90th percentile driver. They actually based on statistical analysis, they multivariate statistical analysis, they created these digital human models. and those they use the digital human model in the cockpit design of that vehicle. For various aspects, reach analysis, vision analysis they have used. After in the paper, they also demonstrated two case study. One case study for seat adjustment range for new vehicle platform, and in another case study reachability analysis for cup holder location. So, in this paper also it was clearly demonstrated that digital human modeling is very effective tool for automotive design process, particularly vehicle design and occupant packaging. Summerskill et al. 2012 in their research paper, they demonstrated that how this digital human modeling can be used for volumetric projection of digital human modeling software for identification of blind spot in category N3 vehicle. So, they demonstrated that volumetric projection in digital human modeling software. So, for blind spot analysis. To establish the cause and nature of blind spot, 3 category N3 vehicle were digitized using scanning system and imported in SAMI-CAD system. So, 3 types of N3 vehicle they scanned and those CAD model are imported to SAMI DHM system, and then different types of analysis was performed. In their analysis, they used a new feature which they developed in this digital modeling system to represent the 3-dimensional space visible to the driver through the mirror. So, while driver is looking through the mirror, through that is the indirect visibility, at the same time while driver is looking through the windshield or cutout portion of the door, that is the direct visibility. So, while they are looking through the window or windshield or through the indirect vision through mirror, then which area is actually visible to the driver. So, for that purpose they created volumetric projection. From the mirror, volume will be projected and that projected area is actually indicating that those areas is actually visible to the driver. So, while driver is on the driving seat and looking at the various mirrors placed, in this particular case there are total 5 mirrors. Through that 5 mirrors, which area is actually visible and which area not visible. That area which is actually not visible, that is called blind spot. So, in this case in N3 vehicle, while that vision analysis was done by creating that volumetric projection, it was observed that in this particular image it is visible that this vehicle which is passing beside this truck, that is actually not, that is actually coming to the blind spot zone, means this is not visible to the driver. This volumetric zone is for one mirror and this is volumetric zone for another mirror, but none of the volumetric zone of the mirror is actually covering this vehicle. So, this vehicle, as this vehicle is in the blind spot, so this vehicle will not be visible to the driver. Similarly, if you look at this particular image, these 3 cycle riders are going and none there is actually in the blind spot zone. None of the volumetric field of those mirrors is actually covering them. So, they are in the blind spot zone. But after that, after following this analysis, they changed the mirror type and they placed a different mirror called SPFAX VM5 mirror. While they positioned that particular mirror, then that eliminated that blind spot zone. So, after that position, while they changed the normal mirror type, normal V5 mirror, class 5 mirror, while it was replaced by SPFX VM5 mirror, then that blind spot zone actually eliminated. So, now from this analysis they clearly demonstrated that with using this type of mirror actually that blind spot zone can be eliminated, and this observation was very important, because due to this type of existence of this type of blind spot zone around the vehicle is actually may lead to different types of accident. So, blind spot from the research shown to have potential to be causal factor in accident scenario that were identified using accident statistics data. So, from this study Samarsky et al. They clearly demonstrated that digital human modeling software is very effective using this type of volumetric projection, mirror projection zone, and identifying blind spot area and how that blind spot area can be eliminated by the design intervention by using different types of mirrors. So far what we discussed in the earlier slides, all these are related to vehicle occupant packaging, visibility, reach, inside and outside the vehicle. Now, we are going to discuss about application of digital human modeling software in automobile digital manufacturing shop floor. So, while digital human modeling software is used by different researchers for assembly process in manufacturing workstation, then how digital human modeling software actually help designers or engineers. So, Lamcool et al. 2009 in their research paper, a comparative study of digital human modeling simulation results so they in the research paper entitled a comparative study of digital human modeling simulation results and their outcomes in reality. So, what results they are getting from the human modeling simulation, and it was compared with the result in reality. So, a case study within manual assembly process of automobiles. So, they investigated to what extent ergonomic simulation of manual assembly tasks correctly predict the real outcomes in the plants. Following ergonomic evaluation of 155 ergonomic simulation by 6 ergonomists at Volvo Car Corporation in Gothenburg, following conclusion were drawn. So, digital human modeling tools DHM tools are useful for the purpose of providing designs for standing and unconstrained working posture. Digital human modeling is beneficial for evaluation of design of various auxiliary devices and their needed space for movement. So, while those auxiliary tools or equipments are being used, how much space is actually required, that can also be defined using digital human modeling study. Study also indicated areas of improvement in the digital human modeling tools application, that is hand access, push pressure, pull forces, leaning and balance behavior and field of vision. So, in this area they identified further improvement is possible in the digital human modeling software. So, overall from the paper it was clearly identified that digital human modeling software can be effectively used for this type of manual assembly process and providing better workstation condition, so that human can do their activities avoiding awkward posture. So, if you see this image where that person need to sit with this awkward posture and then do the assembly work, but now while that vehicle model has been shifted up, then that person can do his work by maintaining this type of relatively better posture. Similarly, for shorter assembly worker, earlier they had to work by raising their hand. Now, after design modification, now that person can do their activity below the shoulder level. So, problems can be identified in virtual environment using digital human modeling software, and as per that evaluation design modification can be proposed, and proposed modification can again be evaluated with digital human modeling software. Now, if these solutions are implemented in real scenario, then obviously that manufacturing industry will be benefited. In the research paper Chang and Wang 2009, that research paper is digital human modeling and workplace evaluation using an automobile assembly task as an example. So, how actually they demonstrated how digital human modeling software can be used in the automotive assembly process. So, for that purpose they used Delmia digital human models, and 3D Studio Max was used for creating the 3D models of the workplace. So, 3D models of the workplace was created in 3D Studio Max, and then it was imported to Delmia software for virtual ergonomic evaluation. So, they stated that integration of dynamic simulation and ergonomic evaluation enables the system designer to visualize and improve workplace design in the digital space. So, task simulation was performed for two automotive assembly process, one is door assembly and another is body assembly. So, two assembly process they demonstrated in their paper, and in those assembly process how digital human modeling can be used. So, ergonomic improvements are implemented in manufacturing shop floor. Following that analysis, even in real life they implemented that improvements. So, earlier in that manufacturing shop floor, workers used to work like this type of awkward bending posture, but then they modified that workstation in such a way, so that person can do their activity in this type of standing posture. Similarly, in earlier case they had to carry the door like this type of bending posture. Now, the door actually is carried with the hanger. Now, that person can stand comfortably in standing posture and do their assembly work. So, just one intervention by using a hanger, it actually changed the posture of the human. So, before that before the design modification, how was the condition? They evaluated using digital modeling software, they analyzed the spinal load, and after modification also they evaluated that how that spinal load can be reduced by design modification of this workstation. Hansen et al. 2012 in their paper digital test assembly of truck parts with IMMA tool and illustrative case. So, in that paper DHM tools called IMMA, mean intelligent moving mannequins, was introduced in 2010. They mentioned that this particular digital human modeling software was introduced in 2010 with advanced feature like advanced path planning techniques to generate collision free and biomechanically acceptable motion of digital human models as well as parts. This IMMA tool was used in combination with path planner, that is IPS, industrial path solution, in the reported illustrative case study. So, the case study which they reported, they not only used IMMA tool, but they also used IPS tool. The major strength of this IMMA tool are the user friendly interface, the motion generation algorithm, the batch simulation of mannequin, and ergonomic assessment method that consider time. Hansen et al. From their illustrative case study concluded that this IMMA ergonomic evaluation, that digital modeling tool actually helps in ergonomics assessment. This IMMA mean ergonomics assessment module is very promising for assessing task analysis and also identifying further scope for development of the tool. So, in the task assembly they use this IMMA tool and demonstrated how that can be used. At the same time, where are the scope for improvement for this particular tool. So, this is that using that IMMA tool they are actually demonstrating here that ergonomic evaluation of carpet assembly task. In this vehicle they are actually putting that carpet on the floor, and in that assembly activity or task simulation they evaluated the posture and different types of lifting, then the various types of ergonomic stressors, repeatability, all these variables they studied. Ergonomic evaluation results from the carpet assembly task. The task is analyzed with Scania ergonomic assessment method and with more detailed time based method for the rest. So, from this carpet assembly task they demonstrated that this new digital human modeling tool which they introduced in 2010, this IMA can be is very promising for assembly task analysis. So, we discussed few of the research paper where in automotive industry various researchers or engineers have used various different types of digital modeling software in combination with motion capture system or force reaction system. So, different types of other system they have used digital human modeling software for various types of occupant packaging as well as for digital manufacturing in automotive assembly task. So, these are only few papers which has been discussed here, but there are many more papers. So, I suggest all the students who are going through this course, they should go through, they should explore more research paper, should go through those paper to understand details about how these digital human modeling software are being used by various researchers in automotive industries, because automotive industry is the largest industry which is adopting digital human modeling at the most. So, these are the references.